Good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we will try to get to as many as we can during the webinar today. Also happening at the end of today's webinar, we'll be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is your organization compatible with Zero Trust? Our speakers today are Virag Mody, who is Enterprise Sales Development at Gravitational, and Ev Kontsevoy, who is the CEO of Gravitational. Gentlemen, thank you so much for joining me today. Really appreciate it.
Thank you, Charlene. Hi, everyone. Thank you for attending this webinar. We really appreciate your time. My name is Virag Mody, and for the next 45 minutes or so, we're going to be discussing the challenges of modern network infrastructure and how it can be tackled with this so-called zero trust security model. Now, our goal here is to sort of separate the marketing fluff from perhaps some of the more salient principles of zero trust. And without a doubt, I'd say the term zero trust has definitely been co-opted for marketing, but I think to dismiss it as such would be a bit of a disservice. So when you cut through the noise, there's something worth uncovering. And so to help us with this exercise, I'd like to introduce my co-host, the CEO and founder of Gravitational, Ev Kontsevoy.
Hey, thank you, Virag. I don't quite like the fact I was introduced as a CEO of Gravitational, but I'm an engineer, and I also don't like marketing fluff. So uncovering what zero trust is all about is very interesting for me personally. A little bit about myself. I was spent some part of my career at Rackspace, a significant cloud provider, where we had 7 different regions all over the world, and each region would be broken into multiple different form factors. We had private cloud and public cloud, and we rented dedicated servers with so much infrastructure everywhere and with all kinds of customers. So obviously we were frustrated with the complexity of how you securely access this infrastructure, how you run the same application in many different regions at the same time. And customers would come to us asking exact same questions. So like my experience there was just to realize that the world is confused what to do with all this complexity, especially with the shortage of talent that we have on security and on engineering side of the business in general. And that's really why we started this company, is just to dramatically simplify like the problem of accessing infrastructure. And yeah, happy to be here and talk about what we can do about it.
Yeah, well, thanks for joining us. So, I'd like to start by saying that given that zero trust is an evolution of ongoing security practices, I think it's important to take a quick moment and just talk about what has changed within organizations that has led to this new way of thinking. And nowadays,
you mean like what used to be before, like, right?
Right, exactly. What came before and what's changed over time. And currently, a lot of modern infrastructure is fairly distributed, whether it's across multiple clouds, whether it's on-prem, if you're using something as a service, what have you. But earlier on, that surface area was significantly smaller, right? Going back to sort of the founding days of networking, where geographically devices were significantly clustered together. The number of devices within a network was definitely more manageable, and all the resources that were being accessed and all the applications were entirely on premise.
So let's kind of dive into that and maybe use like a simpler analogy. So basically what you're describing is what used to be called perimeter security, right? It's a traditional model, and it makes perfect sense. Like back in the day, like even before we had computers, how do we as humans think about security? Like how do we secure our stuff, our possessions? So we basically have, let's just imagine you have an apartment or a house. So everything inside of that house is yours, and you obviously own all of these things: the microwave, the fridge, the TV set. But you don't want strangers to be using these things. You don't want them to come in and eat your food. So you put a door, and actually, I see this slide that Virag put on there. So that talks about perimeter security model. So you have your apartment on the right with all of your appliances inside, like resources. So the door is what you use to regulate who gets access to your stuff. And whoever has the key, that person can come in and eat an apple out of your fridge. In this model, everything that's inside is automatically trusted. So if a person is inside of the apartment, then it means that like the fridge makes no assumptions about that person other than full access, because you are on the inside. And so many of our systems today are basically designed with this, what I would call like apartment security in mind, that we trust you based on where you are, not based on who you are. And if you are inside of the apartment, you're one of us, and if you're outside, you're one of them. So no access. And look, this worked really, really well for a long time.
Yeah, I think you sort of hit the nail on the head there, right? With this sort of apartment analogy, where those within the apartment are considered sort of part of the group, right? They're safe, they're secure, and those that are outside of the apartment are untrusted. And so conceptually, we started with this model where you had like an us versus them sort of topological map of the network. And this was the perimeter model, castle moat model, whatever you'd like to call it. But as networking technology advanced over the time, these infrastructure, right, sort of the complexity within the apartment started to sprawl quite a bit. And we saw devices that were allowed to access the network sort of grow exponentially, and the geographic locations that they were located was spread out. You saw incomplete protections within the network. So, like you were saying, if you were within the apartment, you can open up a fridge, you can open up a microwave, you could do whatever you'd like. And so it was very easy to enter the network and then traverse from one point to another, even if they were completely unrelated. And finally, sorry, working from home. The applications and the systems that organizations are used to using started to communicate over the web instead of just being on premise, right? As you had sort of the API economy explode and you have all these X as a service platforms come out.
Yeah, it's scaling basically. Like we are operating at a much grander scale today. Like think about like a company like Netflix. So imagine you are an engineer on Netflix team. So what does it mean for Netflix to deploy into production? Like what is production for Netflix? Well, it's a collection of data centers all over the world. That's where video is being streamed from, right? So then you have the control plane, all the menus and the store hosted from multiple AWS regions. And maybe they're even using some additional cloud providers to, maybe they're using some machine learning capabilities on Azure in addition to AWS. But then they also have code running in millions of smart devices, like inside of TVs and PlayStations and probably some other things. But then in addition to that, think about the workforce. Do they all sit in the same building? No, but they probably have engineers scattered all over the world, not even in the same country. So it's easy to see that the apartment security model doesn't really work. The house security model is completely broken because Netflix is not really deploying in like within a secure perimeter anymore. Like the deployment target is planet Earth. It's actually like one of the reasons why we called our company Gravitational. So that is really why we are now being forced to adopt this zero trust model. So let's talk about like what does it actually mean, right?
Yeah. Let's jump right into it. So I guess start with the first question. What is zero trust? How would you define it?
So you're asking me?
Yeah, sorry.
All right, so let's move on to the next slide. So if the apartment model is not working, so what does it actually mean, zero trust? Look, as an engineer, I have a strange feeling towards the term zero trust. On one hand, I like it. On the other hand, like simply because it starts with the Z, it's a really cool word, like zero. It's very absolute, very definite. But at the same time, from an engineering perspective, there's like no meaning in it. Like, what does it mean, zero trust? So from an engineering perspective, I think it's a really simple concept. So what does it mean to move your organization towards like a zero trust future, or what does it mean to build a zero trust system? Well, first of all, like going back to the apartment model, it means like the first principle, continuous authentication and authorization. What does it mean? It means that the door shouldn't matter. It means that your apartment is wide open and everyone can come in, but your fridge and your refrigerator and your TV and every resource you have inside, they need to assume that whoever is talking to them is a complete stranger, and they always have to authenticate and authorize. From practical terms, it means that you can just, as an engineer, it's a very healthy assumption to make that every machine on your infrastructure is fully exposed to the internet. There's no firewall in front of it. Every port is open. Not even IP tables is present. Now, design your system to be secure under these conditions. So that's what it means to constantly doing authentication and authorization. And by the way, it's a fool's errand unless you do the second principle, which means encryption all the time. End-to-end encryption all the time, simply because, look, if you're not encrypting, what's the point of authenticating and authorizing if everyone can steal a packet? And finally, I would say the third principle of what it means to do zero trust properly is to authenticate against user's identity and use metadata if possible. So what does that actually mean? Again, going back to previous analogy with this apartment and the door, so whoever had the key could come in. It means that your entire security model was just basically, it was based on possession of a secret. Key is a secret. It's basically a physical object, and it's true with computers as well. But if you're moving into identity-based authentication, it means that you need to authenticate and authorize based on who that person is, and also based on that metadata. So if you combine with the previous principle of continuous authentication and authorization, it means that now you could say, well, if you're an employee of this company and you are an intern, yeah, sure, you could use the TV. I'm sorry, you could use the fridge, but you cannot use the freezer. So combining these three principles, that's what it means, I think, to start moving your project or your little, or maybe your entire organization towards this kind of zero trust future.
Yeah, and I want to sort of call out the difference between what we're talking about with zero trust from the sort of previous perimeter security model, where the implicit assumption, even if you were to use common networking security tools like VLANs, bastion hosts, VPNs, the implicit assumption is still that you can distinguish between people who are allowed in the network and people who are not. But moving to a zero trust model means that no one in the network is trusted to begin with, right? So, Ev, like you were saying, really anything can be exposed to the public internet, but through the methods of continuous authentication and authorization, through identity-based access, and through sort of end-to-end encryption, we're removing this idea that there is a safe space and an unsafe space, right? There is an us versus them that no longer continues to exist. Instead, we have identity-based authentication. We no longer have, location-based authentication authorization.
Exactly. Like location is another. I think it's a good thing you're bringing this up. Is that so frequently engineers, they make security assumptions or even performance assumptions, all kinds of assumptions based on location of something, location of an employee, or like location of a user, and sometimes location of a computing device, like location of a server, Um, and that is a bad assumption to make. So if from the beginning you can just assume that user can come from anywhere, hacker can come from anywhere, and the server itself could be anywhere. Like you don't rely on that server being behind a specific VPN. You don't rely, I'm sorry, behind specific firewall on the VPC, and you don't have to rely on obsolete solutions like that's actually on VPNs. I'm just observing this like interesting phenomena that there's like so many legacy solutions out there, like VPNs is a good example, that they're just now like finding the need, like, oh, we need to urgently rebrand ourselves because VPNs are getting obsolete. Well, let's call ourselves like a zero trust VPN. That makes no sense whatsoever. It's like selling fat free butter. Like VPN by definition, like the value of a VPN, where you say, here's IP address on one network and IP address on another network, and they can now talk to each other. But IP address identifies location. So which means, again, you're making this assumption that it's really important for me to talk to a device at a specific address, which is very much not what zero trust is about. There's probably not a single hard-coded IP address anywhere and Netflix software stack, simply because making these assumptions is just absolutely not something you should be doing in 2020.
Yeah, I think you make a great point. I kind of want to dig into that a little bit too. Sort of this idea that VPNs are becoming obsolete almost seems like a bit of a drastic sort of new way of thinking. But if we take a look at the popular sort of zero trust implementations that already exist, perhaps one of the most commonly known one is Google's Beyond Core, right? And their sort of tagline is networking without VPNs. So let's talk about that a little more, right? Why do you think this concept of zero trust negates the need for a VPN? What's different?
Well, because VPN is the door in that apartment model. So, excuse me, let me just turn off the phone here a little bit. Because if you want location to be completely irrelevant in your system, it means that you need to define, like, these are services I care about. These are my resources. It could be databases, could be API endpoints. It could be like whatever, things you type into your browser or things you feed into, and like a like API endpoint for microservice. So
Just to reiterate, why is location no longer relevant?
Because then you don't have to build your security principles. Because if you make it as your assumption that like this location is different from that location, it means that people will start, like people on your team, they will start to dial in location into like security assumptions. So from a security perspective, it should be completely irrelevant of where particular resource is located. Because if you violate this principle and then you have a hacker at a secure location, then it's not really zero trust anymore. Because in this kind of zero trust world, again, what you should embrace is this assumption that my resource, like maybe my database or my microservice, is running on a machine accessible from a public internet. So that's what it means to have no location, because it has an endpoint. It could be hit from Australia, it could be hit from Africa. Like you're not limiting access to that machine from a specific VPC anymore. Again, you don't have to do that. That's the assumption. That's healthy to make. So if all of your resources within your organization are built and protected with this assumption, then of course, sure, put them on a VPC. But now if someone breaks into a VPC, it absolutely doesn't matter because everything is designed with this assumption that it's in an open internet. And that's why VPNs kind of makes no sense from security perspective, simply because they just represent a door into your apartment. And if you're saying apartments don't matter, then why would you need doors?
That actually reminds me of there was a really prominent hack that happened back in 2014. So Target, the retail store, was the victim of a major hack. I think like thousands, if not more, or like tens of thousands of email and credit card information was released and stolen. And I think the way that happened is really indicative of why the perimeter model is no longer sufficient, or at least this way of thinking, geographically basing your location is no longer sufficient. So what happened was Target had contracted a third-party vendor as for HVAC services, and the data that was being gathered by this HVAC service was fed into Target's larger network. And so what happened was there were these hackers that somehow got the access credentials to that HVAC unit, to that HVAC network, and were able to transverse from the HVAC unit all the way to the payments network within Target, because once they were accepted, right? We talked about this, once you're within the perimeter, you are an accepted, trusted agent. And there are no real restrictions within the network, right? There's no sort of, or very minimal additional segmentation. And so they were able to move from HVAC all the way to payments, and were able to get away with all this credit card information. And this was 2014, right? Not a very long time ago.
Not a long time ago. Yeah, it's basically like calling a repair technician to come and fix your AC in your apartment. And if you're using perimeter security, whoever hacks that technician, they get access to your fridge and they eat all the food. So, which means that your fridge should never trust anyone who is in the apartment. So this is where zero trust comes from. So you see, it's not just marketing bullshit. It makes perfect sense. This is why at the end of the day, I tend to like the term.
So if you were to contextualize the Target hack in the terms of zero trust, right? If we're looking at this diagram on the screen right now, how could things have gone differently if they had a different model?
So an organization like Target, so they would need, first of all, to have a single source of truth that enumerates all people and all pieces of software, basically all robots that should have access to resources. So you could use things like Active Directory for it, Okta. There are plenty of identity kind of platforms out there. You could even use things like GitHub or Google Apps. So then they should have created like a special group called maintenance for, I don't know, HVAC, right? And they should have added people who have access to HVAC to it. And before that contractor showed up, they should have asked for a certificate, because certificate-based authentication is way better than key-based authentication because it includes all of this metadata about the person, and it also expires automatically. So the like maintenance people, they would use that certificate to access HVAC. And in the apartment analogy, it means that the certificate will, like the fridge will give him access denied, the TV will give him access denied, everything in that apartment will be completely locked down, and only the air conditioning would be available for servicing. And even that would be automatically revoked at the end of the day, because that's really how certificates work. I'm also noticing we're not really talking about Teleport, which is our solution we're supposed to plug, right? Because that's exactly what Teleport does for your infrastructure, for your SSH nodes and for Kubernetes clusters. So it basically completely moves away from keys and implements all of these zero trust principles for all of infrastructure access. Anyway, in this case, like going back to Target, even if that contractor was compromised, okay, someone would have hacked into a fridge for 8 hours, not fridge, I'm sorry, the air conditioning. So, but the damage would have been limited both in scope and duration.
And so that sort of brings me to my next point. This topic of zero trust has gained a lot of momentum in recent years. I think originally it was sort of proposed by an analyst at Forrester, I think back in 2010. But recently we're seeing it a lot more. We went to RSA earlier this year, and it was sort of plastered everywhere, right? So what has changed? Why now? Why are we having this discussion now and not 3-4 years ago?
Actually, I think we did start this conversation 3-4 years ago. But if you say like, why not 10-20 years ago? Look, I think it's a carrot and a stick kind of situation. On the stick side, something is pushing us. Like we basically have no choice but to adopt this model. And the short answer there is scale. So my Netflix example, like it might sound extreme to you, but generally what happens with technology is that what is extreme today will be the norm tomorrow. Like today, like you can go to like San Francisco startup scene and you will notice that there are like tons of startups, like companies with 15, 20, 30 employees, and they already have multi-thousand server farms. They already use multiple cloud offerings. They already want to have presence in Asia. So, and they already have people who are remote. They already have employees who want to use their own devices. They're already using contractors and security auditors and whatnot. And look, that's like a 2-year-old company, and they're already having to solve the scale problems that used to be common for large companies in the past. So apartment-based, perimeter-based security doesn't work for them anymore. So that's the stick. And now on the carrot side, we are now actually starting to get a new generation of tools that embrace this design by default. So it's just getting easier. And sometimes these tools are even more convenient than the old tools that we used to have for security, for perimeter-based security. Again, Teleport, our own solution, is kind of similar to that. Again, it's open source, just like OpenSSH is. It has exact same command line. It doesn't require you to hire security professionals because it has all these defaults dialed in already. Basically gives you zero trust by default, and you have to put in a lot of effort to misconfigure it. So, and the combination of these factors is what I think is moving us slowly into that direction.
Yeah, and on the tool side, I also want to mention, I think this growing trend of designing applications using like microservice architecture, specifically the tools that are enabled by like Docker and Kubernetes, one of the key tenets of Zero Trust is being able to sort of wrap each individual resource around with its own sort of like security protocol, right? This ability to authenticate and authorize based on the identity provider. And originally, when you had these monolithic applications, you weren't able to sort of abstract these individual services, but now using microservice architecture, you can. And as a result, all these individual resources, whether they're databases, whether they're applications, whether they're infrastructure, they themselves can be accessed using certificates, which isn't exactly possible for certain applications that are already in productions when we're talking about, say, like legacy companies, right? And that leads me to my next question, which is, is zero trust really achievable for all organizations? Is that something that whether you're a fresh startup 1 year out, or if you are AT&T and you've been around for over 100 years, is that something that you can, meaningfully achieve?
Again, everything is on a scale, right? So we all have legacy systems. We all have things we've invested in the past, and they're working just fine. And we managed to secure them, and they're dealing just okay with the scale we have. Again, don't fix that's not broken. That's obviously something that's important to keep in mind. Like, don't re-architect for re-architecting's sake. But also, let's keep in mind too that, like, even today when you're starting a new project, and look, software is not built from scratch. We're always standing on the shoulders of giants. Like, we use like a ton of open source in production, but it's important to pay attention to the defaults. Like, for example, this weekend, you probably saw it in the news. There was this a new hack that someone was deleting thousands of databases all over the internet, right? It's because people had their database servers like completely unprotected. So why are they exposed? Well, it's just because most databases, when you install them by default, their default configuration is not like zero trust friendly. What does it mean? Like, encryption is not turned on. Even authentication is not turned on. If you do, like, if you on Debian or like Fedora, like you apt-get or RPM install like MySQL, and then you get it up and running. So what you will see that MySQL is listening on unencrypted connection, and there is no username and password. Most of the time, but not always. Like, it might be limited to localhost connections only, but it might not. But even that is, again, like a little bit of violation of open trust, because if you're only listening on like localhost, you're assuming that who is on this machine that can access you. But anyway, so it's just dealing with this kind of legacy baggage of like wrong defaults, I think is a kind of big obstacle, which means that an organization, in order to implement zero trust, like yes, you do need you need to have a certain degree of kind of technical competence in your teams. Having teams who understand at least some security is important, which brings me to this kind of like one big overarching problem for all of this thing is basically talent shortage. We see talent shortage everywhere: design, development, security, infrastructure security. It's hard to find good people everywhere, which brings me back to again, like if you don't have a competent security team, just pay attention to products that are easier to use, like open source. Don't and based on open source and open standards, because it gives you flexibility to move around. And that's really what Gravitational exists to help people with, is that we are like open source, open standards company that tries to make tools that doesn't require a PhD in infrastructure security to operate. And look, we're not the only company that does that. Again, HashiCorp Vault is another fantastic example of you get something complex wrapped in a really, really neat package. And there are other examples out there. So yeah, so companies that are not Netflix, companies that are not Google, they need to look for solutions that that are built to kind of mimic and emulate Netflix and Google experiences, but with much smaller requirements to kind of level of talent that are using those solutions.
So I want to get to the attendee questions in a second here, but sort of just to wrap up here, talking about legacy organizations, what do you think are some blockers for zero trust adoption, right? If you're looking for the right tools, if you're looking for the right talent, what are some challenges you can expect along the way?
Well, I think I mentioned a couple of those. We can just quickly go over again. So a lot of our solutions that we're forced to build on top of, right? Because there is, for example, no better open source relational database than Postgres. For most operating systems, the way you install Postgres, no, it doesn't have encryption turned on. And sometimes it doesn't have authentication. So it's just dealing with older software that actually Postgres supports all these things. You can turn all of this on, but this kind of culture of having defaults that are optimized for ease of use as opposed to security. So that is definitely a challenge. And the second one is this confusion that exists in the marketplace, because look, there are plenty of legacy vendors out there. They already built their systems. I was using VPN as a poster child of that, but there are other technologies that basically make zero sense in the zero trust world, but they will be rebranding themselves. They will be slapping like, hey, now built with zero trust in mind. And just making those technology choices is sometimes complicated.
That's the marketing fluff, right?
Yeah, the marketing fluff
really
gets in the way.
Turns
Absolutely.
off the engineers. Well, thanks, Ev. So why don't we jump right into the audience questions now? It looks like we have a few. Charlene, do you want to take over here?
Yeah, absolutely. We have received a couple questions, but there is plenty of time for audience questions. If you do have one, just go ahead and use your GoToWebinar control panel and submit your question. Let's dive right into the first one here. So this is for you, Ev. So when you said zero fat in butter, I think fat in butter. I think of fat in butter as a good thing. What is a good thing about zero trust model in regard to the fat or certain dependencies like certs? And how do you compare that to something like JumpCloud, or how do you compare to something like JumpCloud in regard to extending Active Directory and or replacing Active Directory?
I like this butter. Look, I also like fat in my butter. I was referring to that, like buying zero fat, like no fat butter is a bad thing.
Right.
I think we are on the same page.
Yeah.
I haven't looked at JumpCloud for a while, so I don't exactly remember what their today's offering looks like. But extending Active Directory or like replacing Active Directory question is a interesting one. Like I wouldn't replace Active Directory. Active Directory is a fine storage for your groups, for your users. Like this is it could be that a single source of truth that you need in your organization to keep your workforce organized. But extending there, it means that all like your like let's say you running internal application for your organization, and if your applications that are building yourself, if they have their own users databases, if they have their own role-based access controls, if they have their own group definitions. So this is you drifting away from this kind of zero trust concept because you already have all of that in Active Directory. So just configure everything to authenticate users based on Active Directory identity. Configure everyone to configure your application, so build your application to enforce role-based access control that you have already defined using Active Directory. So just utilize these investments you've made previously. And then there's like obviously these kind of technical bits that turn on encryption, because if encryption is turned on, then it makes no sense if you're using these things or not. Which also brings me to the second question I see there in chat. It's like, how do you achieve zero trust? What are the steps to follow? Again, it's a really broad question, and if we remember that everything exists on this kind of spectrum, so you can slowly marching towards it. Start with the simplest thing: just enable encryption everywhere. Even with it's what's interesting is that most products and the most open source solutions, they always give you this choice, and there's always this kind of default thing. So what I like about the newer tools, that they make encryption easier by default, and they make you do extra work to not have encryption. For example, like Kubernetes, right? We're all migrating to Kubernetes. So you can run Kubernetes on, and Kubernetes uses etcd as a data store. You could install etcd without encryption, but you have to type something like dash dash, like warning dangerous dash dash unencrypted. No, like don't do that. Just generate certificates, seed your cluster with certificates, make sure etcd is encrypted, because otherwise, like, what is the point? Because all of Kubernetes security machinery that comes later, they will be compromised forever because your etcd, which stores all of these things, is going to be unencrypted. Yeah, start there, and then start migrating your applications to respect identity stored in your Active Directory. That would be next step. Again, our solution Teleport, it does this for your infrastructure access. So a lot of organizations we see today, they have their regular users, people who work in accounting, marketing, whatever. They have this as the corporate SSO, second factor, all of these wonderful things. And then they have engineers that live on an island. They say, well, we engineers, we don't need all of it. We're just going to use this SSH keys that we're going to store in 1Password or whatever. So that's your weak link. Like, why don't your engineers using exact same identity-based authentication to access infrastructure, to run deployments? So that's basically where Teleport goes. Again, you don't have to pay us for it. It's open source. It comes with all these things. Start there. So that would be a good first step.
Excellent. All right. Well, we've gotten a couple more questions, and actually, before we get to those, there was another question in the butter fat question that we didn't address, and that is, what is a good thing about zero trust model in regard to the fat or certain dependencies like certifications?
Hold on. I'm trying to find dependencies like certifications. I'm not sure I understand what that means. If the person means that zero trust is a little bit more complicated because now you need to set up certificate authorities, yes, it is true. And this is what I was referring to, is that if you were to go and implement all these practices just absolutely from scratch, you will have to have a competent security team that knows how to set these things up. But we are now moving into this world where there is new generation of solution providers who take care of these things for you. Again, I already plugged our own product multiple times, but look, I encourage you to use Google, and I already mentioned HashiCorp Vault. Like, Vault can be used to issue certificates, for example. Yes, you have to invest in this basic infrastructure to set this up.
All right.
If you don't mind, I also want to take a crack at this question. So another thing that I want to mention, looking at the diagram here, There's a major difference between the way that, say, certifications integrate themselves into a zero trust model versus something like, simple impersonal dumb SSH keys. And the important thing there is that these certificates contain a lot more information about the identity of the person or the machine that is trying to access these resources. And so you can implement rules based on the metadata included within these certificates. And you can say things like, okay, this role is an intern, therefore they are not allowed access to staging environments or production environments. They're only allowed access to dev environments, right? Or we see something like the auditing logs here, and you can sort of recursively use that information to create even more narrow enforcement policies where, if you have some type of log saying, okay, this person ran this command, automatically revoke their certificate because they're not allowed to do that, right?
Yeah. So yeah, you're basically referring to this question that I think Ken was asking, the thoughts on role-based versus attribute-based. Like role is just an attribute. It's just one of these things that you could use to reason about like what kind of access a person could have. So one of these capabilities that we're working on Teleport side is specifically, it's called like workflow API, or it's like custom authorization. It's like you want in your organization to implement all kinds of rules. Like maybe sometimes it could be a silly rule. Like if your last name starts with a K, you should not be able to access MongoDB staging instance between 2 and 4 p.m., right? You will never be able to implement this rule using like roles, right? But if you can implement, like if you could write like a tiny Python script that takes, it's basically a function that takes a person's identity and then it like put all this logic in there in Python, and then it outputs like a Boolean value, true or false, access denied, access granted. So you can feed that into Teleport, and every time trust like someone to execute a SSH command or access a Kubernetes cluster, like we will run that for you. And so that allows you to implement any kind of security policy you want. So this is kind of the future that we're slowly moving towards, and look for solutions that enable similar capabilities for your systems.
All right, great. We have a question here about the overhead that zero trust adds to existing systems. What do you think about that? Is that a misnomer? Is it something that organizations need to contend with?
So if I understand properly, what does zero trust add to existing systems? So maybe I missed it.
Yeah, the question is, what do you think about zero trust and the overhead it adds over existing systems?
So I think, look, we have, like, not being dogmatic is important. Like, let's do what makes sense. Personally, when I see like what tools and solutions we use internally, a lot of software, even legacy software, can be configured with this kind of zero trust principles in mind. Like our Jenkins server, for example, is configured, like it pulls identities of developers from GitHub. We turned off its own internal database of users. Obviously, encryption is enabled. Like even, like for example, even if we don't expose Jenkins publicly, it's still on a fully protected HTTPS endpoint, even if we're only hitting it externally. It means if someone ever, for example, borrows my laptop and then tries to do something on Jenkins, well, they still have to go through GitHub SSO to touch the Jenkins instance. So it's a perfect example of super legacy thing that we configured according to those principles. Again, zero trust is not a new technology. It's just a set of assumptions that you just assume that are true forever and ever and ever, and then you use whatever tools you have to implement them. I also wanted to address Alan's question, is that he says that certificate management is a nightmare. Yes, it has always been, and it's becoming less and less so. We, on one hand, as engineers, we understand that certificates give, like they have superpowers. They give you this magical ability to have this apartment where all of your devices, like let people use like portions of what's inside, like freezer versus the rest of the fridge. Okay, no question. And they expire automatically, and they give you fantastic audit logging, by the way, because inside of a certificate, you can inject so much metadata, and all of that goes into your audit log that like you will not get a rich visibility like that if you let people use just binary keys. Now, on the management side, we just need better tools. Like if you ask me like why we started Gravitational and built Teleport, we actually had it on the slide because specifically to make it simpler. Teleport has a automatic certificate rotation. Like your entire cluster, all of your nodes, all of your users, everything is certificate based and it's fully on autopilot, and you could have a sysadmin that manages it without even understanding what certificate is. So that knowledge is no longer necessary. And this is actually what happens with technology in general. Like we move forward and the tools become simpler and more powerful at the same time. Sometimes like they become more powerful and more complex, but eventually we get it, we figure this out and we simplify. That's really what this industry is all about.
All right.
So yes, it's complicated, but it's temporary. We're working on it.
Excellent, excellent. Well, a quick reminder to the audience, we have probably about, I don't know, 7 minutes or so left in our question and answer period. So if you have a question, please go ahead and use your GoToWebinar control panel and submit it, and we'll just keep rolling right along here. Let's see, we do have a couple more questions. Does the presence and number of custom applications along with potential inherent technical debt present a challenge to enterprise adoption? If you believe so, what are some ways forward to overcome this challenge to successfully implement zero trust models?
So this question is related to the previous one. Look, and sometimes answer is, there's nothing that can be done. Like, I'm sorry, but this is true. I have seen legacy systems that are just engineered, I know, like to run on a single super protected server, and there is nothing that could be done about it. And maybe the answer is like, don't waste your time and just move forward, and whatever new projects you're starting, let's just make these assumptions true. But sometimes it still pays to at least do an audit. Like you say, these are 5 things we try to make true. Let's go and audit what we have today and see what would cost be to try to, like, again, turning encryption everywhere. Sometimes it's really expensive and it's nightmare. Sometimes it's relatively painless. Again, I don't want, like, I'm not one of these technologists that like who always advocates for the latest and greatest. I do understand that system, like the maintenance, is very complicated topic, and yeah, sometimes there is no easy answer. I can't, like, not in 45 minutes on a webinar with a stranger on the internet.
All right. Or maybe in a bar with a beer, and
Yeah, like case by case basis.
So,
Like, it's always interesting conversation to have, but just I would not try to generalize here because I understand that people's jobs and budgets depend on it, and availability. It's a serious business.
absolutely, absolutely. All right, guys, have a couple more minutes left, so go ahead and get your question in if you have one. Here's one for you. What is a developer-friendly description of zero trust?
Oh,
Not that they don't understand the refrigerator concept.
we can go to those 3 principles and just compress them to like 3 words. Continuous authentication, authorization, encryption, and everything needs to be based on identity, not on a binary key.
All right.
So now it's not bullshit anymore, right? If we use very serious sounding words.
Exactly. Nothing marketing fluff about that one.
Yes.
Okay, next question here. Are there any drawbacks to zero trust?
Oh yeah, we just covered it.
Yeah.
The increased complexity, especially in the early days. There is no doubt in my mind that eventually it will be factored into all new software. It will be the default. It will be actually the easiest way to set things up. But right now, in a transitional period where everything takes a little bit more effort.
Okay. All right, guys. That's actually our last question right now. So I think, Virag, I'm going to go ahead and send it back on over to you so you can do your conclusion, and then we'll move forward with the Amazon gift card drawing. So.
Yeah, sounds great, Charlene. Thank you. So, we're coming up on our time here. I want to thank everyone that took the time out of their busy schedule to attend today. We're very grateful, very appreciative. It's nice. So we've covered quite a bit in the past 45 minutes to an hour about zero trust, and specifically how its principles are better suited to handle the security challenges that modern organizations face today. And before we sort of wrap up, Ev, is there anything else you'd like to mention before we close off?
Not really. Like really happy to be here. Thank you all for showing up. Thank you for very insightful and real world questions, because I do understand that we're all facing very difficult situations. Again, to remind everyone, especially engineers, what zero trust means. It's continuous authentication, authorization, and encryption, and you authenticate and authorize based on identity. Again, and go check out what Gravitational does, because we would love to make this much easier for you. But like the only problem we focus on right now is infrastructure and Kubernetes access. So we're not really we can't really help you, not yet, with like zero trust answer to all of your needs. But at least on infrastructure level, I do think we have pretty easy to use solutions.
So if you'd like to learn more about zero trust, modern security practices, or really just Gravitational as a whole, feel free to check out our blog at gravitational.com/blog. Follow us on Twitter at gravitationalco, that's gravitationalco. And on behalf of everyone here at Gravitational, have a nice day, take care, and be safe. Charlene?
All right. Yeah, all right, great. Thank you, Virag. Let's see. I'm a little off my schedule here. So just want to remind the audience that today's event has been recorded. So if you missed any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we are going to be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website. So you can always go find it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, I did mention at the top of the hour that we would be doing a drawing for 4 $25 Amazon gift cards. So without further ado, let's go ahead and do that now. Our first winner today is Frank R. Congratulations, Frank. Our second winner today is Ken L. Congratulations, Ken. Our third winner today is Myron L. Congratulations, Myron. And our final winner today is Nicholas D. Congratulations to all 4 of you, and please check your inbox. We will be sending you information on your Amazon gift card. If you don't see it in your inbox, please check your spam folder. Ev and Virag, thank you both so much for a great presentation. Lots of good, interesting information. And Ev, I have to tell you that your refrigerator analogy has made me hungry. So I'm going to go have lunch now.
Yeah, gotta keep your food here.
Exactly. Thank you both so much for your time, your expertise. I really appreciate it. And I know the audience did too. So thanks again.
Thank you, Charlie.
Thank you.
Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Please stay safe.